part of speech tagging is the process of labeling each word in a sentence with its grammatical role. For example, whether it's a noun, a verb, or an adjective. This helps us understand not only the meaning of the separate words, but how they function in a sentence. To perform part of speech tagging in Python, we'll use the Spacey package. Spacey is one of the most popular NLP libraries. It comes with pre-trained models that can recognize parts of speech, named entities, and other linguistic features right out of the box. We'll also use pandas, which you already know is great for storing and working with structured data. In this lesson, pandas will help us organize the tagged text into a clean format so we can analyze it more easily. Okay, the first step is to load a Spacey model. We start by creating a variable called NLP. Then, we use the function spacey.load. Inside the parentheses, we specify the model we want to use, NCore Web SM. This English core model is lightweight and fast, which makes it perfect for learning and for smaller projects where speed matters more than perfect accuracy. By loading it into the NLP variable, we now have a ready-to-use tool for processing English text. Next, we need some text to practice part of speech tagging. For this example, we'll use a passage from Emma by Jane Austen. Emma is a classic English novel from the early 1800s. It's often used in natural language processing because it's freely available as public domain text. For simplicity, the text has already been pre-processed a bit, punctuation has been removed, and all words have been converted to lowercase. However, we've kept the stop words, since part of speech tagging also applies to those common words like the, and is. Now we'll create a Spacey document from our text. A Spacey document is an object that stores the text along with all the linguistic information Spacey generates, such as tokens and their part of speech tags. This single line of code takes the text from Emma and turns it into a structured document where each word is already tokenized and tagged. Okay, let's now create an empty data frame called POS We tell pandas that this table should have two columns, one named token and one named POS tag. Then we use a for loop to go through every token in our Spacey document. For each token, we grab two pieces of information, the word itself and its part of speech tag stored in a dictionary. We then turn that dictionary into a one-row table using dataframe.dot from records. Next, we join this one-row table to our larger table, POSDF, using pandas concat method. This process happens over and over, once for each token in the text. By the time the loop finishes, POSDF has grown into a full data frame, with one row for each token and its part of speech tag. Once our table is ready, we can take a quick look at it. By running posdf.head, open parenthesis, 15, close parenthesis, we display the first 15 words of the text along with their part of speech tags. Nice! Let's dive a bit deeper. Say we want to find the most common tokens and their associated POS tag. To do this, we create a new data frame from the previous one and call it POSDF counts. Inside this table, each unique token and its tag will be grouped, and we'll also count how many times they appear. Here's how it works step by step. First, we use the group by function on POSDF, grouping by both the token and the part of speech tag. Then we use dot size to count how many rows belong to each group. Next, we use reset index. This is important because after grouping, pandas uses the grouped columns as the index of the table. Resetting the index turns them back into regular columns, so our table looks clean and easy to read. We also give the new column the name counts. Finally, we use sort values with ascending set to false, which makes sure the most significant counts appear first. When we run POS dfcounts.head, we see the 10 most common tokens, along with their POS tags and how many times they appear. For example, in our text, some of the most frequent tokens are of and her, together with their tags and occurrence counts. Okay, let's find out how many different words fall under each POS tag. We create a new data frame called POS df POS counts. Here, each row will represent one part of speech tag, such as noun, verb, or adjective, along with the number of unique tokens that belong to it. Here's how it works. We use the group by function on POS df counts, this time grouping only by the POS tag column. Then, for each group, we count the number of tokens using .count. This gives us the number of different words for each part of speech. Next, we use sort values with ascending set to false. This puts the largest groups first, so we can immediately see which part of speech tags are most common in the text. Finally, we obtain a list of the most common part of speech tags and their counts. Nice. Okay, let's get more specific. To look particularly at the most common nouns in our data, we can filter the POS df counts data frame to include only POS tags that equal noun. From there, we select the top 10 nouns by their counts. When we print this out, we see that the top nouns are governess and friend, both appearing 3 times, followed by mother, daughters, sisters, and others.